Hello everyone. So in this video we will learn about matrix multiplication. We will see how to optimize the running time of matrix multiplication using dynamic programming. The running time of matrix multiplication is basically depend on the number of multiplication we are doing in the matrices. So this video we will see that how dynamic programming is applicable to improve its running time. So if we want to multiply two matrices, the fundamental property is two matrices are only can be multiplied if they are compatible. Compatible means if we have two matrices, the first is or 2 cross 3 and the other is 3 cross 4, then they are said to be compatible if the column of the first matrix is same as the row of the second matrix. If they are compatible, then only you can multiply, and the number of multiplication that are required to get the product of to get this product AB will be 2 cross 3 cross 4, which is equals to 24. Now we'll see one example and then we'll understand how the dynamic programming is helping us to get the optimized running time. Let's say we want to multiply three matrices and the order given is for matrix A this is 20 cross 30, and for the matrix B let's say this is 30 cross 10, and for matrix C this is 10 cross 40. Now if I want to find the product of these three matrices, so let's say if I multiply A into B first, and then if you multiply A into B you will get the AB of order 20 cross 10, and the number of multiplication required is 20 into 30 into 10, which is equals to 6000 multiplication will be required. Now if you multiply this AB into C with order 10 cross 40, then you will get this ABC of order 20 cross 40, and the number of multiplication required will be 20 into 10 into 40, which is equals to somewhere 8000. So the total multiplications we are doing to get the product of this is 6000 plus 8000 equals to, you can write here 6000 plus 8000, which will be equals to 14,000. Now we will be multiplying the same matrix in some different way. Let us take I am multiplying first B into C. So if I multiply BC, I will get the matrix of order 30 cross 40, and the number of multiplication will be 30 into 10 into 40, which will be equals to somewhere 12,000. And then I will multiply A, that is order 20 cross 30, in with B into C, then the number of multiplication will be 20 into 30 into 40, which is somewhere 24,000, and the total of multiplication required will be 36,000. So you can see here that for these three matrices, if you want to get this answer ABC, and if you are multiplying in a different way, if you are multiplying in AB into C, this is your answer. If you are multiplying BC and then multiply with A, this is the answer. And you can observe here there is so much difference. This is more than double multiplications are required. That means it is very important to identify the correct order to reduce the number of multiplication, which is the basic component of the running time. So using dynamic programming we can find out that what is the optimal subsequence to get the optimal answer. So to get the answer means optimal answer, the naive approach is you can try with all the possible combination. That means if I have to multiply A, B, C, D, then I may be using either A, B and then C, D, or I will be doing A, B, then C and then D, or I will be doing B, C, then D and then A. So there are many possible combinations are there, but it will be again a very costly operation if you try with all the operations. So we are looking for some optimal approach that gives us the optimal subsequence to reduce the number of multiplication. So that is how this dynamic programming helps us. So for dynamic programming, we have one formula. This is the formula which we are using to solve our problem to find out the minimum number of multiplication. So if I equals to j, so we have I and j, and if they both are equal, this will be 0, otherwise we will be using this formula. So let us understand the scenario. Let's say I have to multiply some ai to aj matrices are there. I want to multiply all of them. So I am looking for an optimal sequence so that the number of multiplication will be the minimum. So let's say the optimal sequence is given by first multiply ai to ak and then multiply ak plus 1 to aj. This is what we are assuming. Now to get this particular optimal sequence, we will be using this formula. So mij equals to mik plus mk plus 1j pi minus 1 pk and pj, where I minus 1, now this part is basically deals with the dimension of the matrix, and k is something which is more than equals to I and less than j. So when we'll take one example, you will be easily understand what does it, how to use this formula. So okay, so uh, to see how we can use this formula, let's say we need to multiply these three matrices A, B and C of this given dimension. So here you can see in this formula we are using some value pi1 pk something. So this is actually p0, this is p1, this is p1, p2, p2 and p3. And because we have three matrices, so we need to make one 3 cross 3 matrix. We want to, if we have 4 matrices, then we make an 4 cross 4, and we will be only want to fill the cell of this matrix where I is more than j. For I less than j, there is no need to solve anything. So this is I less than j, I less than j, I less than j, and for I equals to j, we will be filling all values 0. So we need to fill only these three values. The basic property of dynamic programming is it uses the optimal substructure. Optimal substructure means to find the optimal solution for any problem, we will be solving optimally all the subproblems of that problem. And this is a fundamental property of dynamic programming. And also we are using a memo, internal some storage to store the intermediate results. So we'll see how we can use the optimal substructure. Optimal substructures means if I want to find out M13, so rather than finding M13, I will be solving the subproblem, that is M12 and M23. Okay, so let us take one example. So first I need to solve this M12 and then I will solve M23. We will be solving in this manner, not in this manner. As I told you, to solve this M13, you need to get the value of M12 and M23. So we will solve in this order. So first when I solve M12, so I am using this formula. So M12, where this is actually I and this is actually j, and we have something k which is greater than equals to I and less than j. So if you look into this value, we have only one possibility, k is only one possible here. So if we have more possibilities of k, then we will take the value which is which is minimum. This is minimum. So we will be applying this formula for all the k's, and whichever k is minimum, we take that particular value. So here actually we have only one value, so there is no choice of finding the minimum. So M12 is given by, now assuming k equals to 1, this will be M ik, I is 1, that is 1 1 plus M k plus 1 will be 2 and j is 2 plus pi minus 1, that is p0, because I is 1 here. So P0 is what? This is 2 into Pk is 1. So P1 is what? P1 is 3, and then Pj. J is what? J is actually 2 here. So P2 is 2. So when you solve this, now here you can see this M11 where I equals to J is 0, where I equal to J is 0. So this is 0 plus this is will be 12. So you can write this value here 12. Now the next we need to find, now we have two more cells remaining. So first we solve this one based on the optimal substructure property. So I am going to solve M23. So M23, here I is this and J is this, and we have K greater than equals to I and less than J. So here we have only one K possible, that is equals to 2. We cannot have K equals to 3 here. So again I am writing this formula Mik using this. So this will be 2 comma 2 plus M K plus 1J, this is 3 comma 3 plus Pi minus 1. So I is 2 here, that is P1, that is 3 into Pk. K is 2 here, so P2 is 2 into J. J is 3 here, so P3 is 4. So you'll get here, this is I and J equal, this is 0 plus this is will be 24. So you can write this here 24. Now we have left with this cell, that is M13. Now here you can understand that why we need to solve in this way, because to solve this M13 we need the values of M12 and M23. So here you can see this is I is 1 here and J is 3 here, and we have K which is less than equals to I and less than J, or you can say which is greater than equals to 1 and less than 3. So we have two possibilities of K. We have K equals to 1 and K equals to 2. So we will find each value for K equals to 1 and then K equals to 2. So for K equals to 1, if I solve, then M13 will be M11, this is Mik, where K is 1 here, plus M23 K plus 1J plus Pi minus 1. So P0 is what? P0 is 2. K is 1 here, so this is 3 into Pj. J is 3 here, so this is 4. So you can find here this is 0, and M23 we already find out this is 24, and this is 24, which is equals to 48. Now I am solving here for K equals to 2. So when you solve M13, you will get M. Now here K equals to 2, you will get M12, that is Ik, plus Mk plus 1J, that is 3 comma 3, plus Pi minus 1. So I is actually 1 here, so which is 2, and K is 2 here, so P2 is 2 here into 4. So this will be M12 already we have solved, which is actually 12 plus 0 plus this is 16, which is equals to 28. So we have two values, one is 48 and one is 28, and this is for K equals to 1, this is for K equals to 2, which this is minimum, so we will take this value, this is 28, and we will write here 28. Now this tells us that the number of multiplication required to get A into B into C is 28. So 28 is the number of multiplication required to multiply this. Now we are looking for the sequence, means how to multiply. Either we need to multiply AB into C or A into BC. This is still we need to find out. So this depends on the value of K here. So because we are multiplying the three matrices, so this is our final answer. If we have five matrices to multiply, then we are looking for cell 1 5. Here we have three matrices, so we look for this M1 3, which gives you the value 28, and this value is coming for k equals to 2. That means if I write a1, a2, a3, then at k equals to 2, this is where we have to split. So this is the optimal sequence to multiply a1 into a2 into a3. So hope you have understood how to multiply the matrices in an optimal way using dynamic programming, and also how to find out the sequence. So I would like to take some more example to find out the optimal sequence. Let us see some more example here. Okay, let us understand here. Let's say we have five matrices given to us, a1, a2, and a3, a4, a5, and we are assuming that they are compatible to multiply, and we want to find the optimal sequence so that we can get the uh, optimal running time. So we are looking for this m, because we have 5 multiplication, so our answer will be in this cell m15. Let's say m515 is given as 3. This is one case. Or if m15 is given as 2. Now if this is given as m15 equals to 3, that means our multiplication will be in this way. We will be doing a1, a2, a3, and then a4, a5, and definitely uh, because this is already means shortest combination, we cannot split further. Now we need to split this, so we will be in our solution, then we will look to m13, means we need to split further this. And let's say if m13 equals to 2, that means we need to split like this, a1 into a2 and then a3, and then multiply a4, a5, and then multiply this together. This is how we are going to do it. Now let us take another way. If m15 equals to 2 in this sequence of matrices, that means we need to multiply in this way, a1 and a2 together first, and then a3, a4, a5 should be multiplied together. Now this is already the smallest format, we cannot split further, but this is to be split further. Now when I say split, means we need to identify either we are multiplying a3 into a4 first or a4 into a5 first. So to get this, we will be looking to the cell a35. So let's say a35 is 3, for example. That means it should be multiplied in this way. First multiply a1 and a2, and then we need to multiply, means a4, a5 will be one set, because we are splitting with 3. That means it should be splitted by the third matrix. That means first multiply this, then multiply this, then multiply this, and then multiply this. This is how we are multiplying to get the optimal answer. Hope you have understood how to multiply the matrices using dynamic programming to get the optimal solution. Thank you very much.